At the southern tip of mainland Greece, where the Peloponnese narrows into a rocky finger pointing toward Crete, there is a peninsula that time forgot. Stone towers rise from the cliffs of the Mani, built without mortar, some of them older than the Ottoman Empire. The people who live among these towers call themselves Deep Maniots. They speak an archaic dialect. They organize their society around male family lines, and for centuries they have claimed, in songs and oral histories passed from grandparent to grandchild, that they descend from the ancient Greeks. Most historians treated this as folklore, a charming local myth. But in 2026, a team from Oxford, Tel Aviv University, and the University of Athens extracted DNA from 102 living Deep Maniots, sequenced their Y chromosomes and mitochondrial genomes, and compared them against more than 1 million modern genomes and thousands of ancient ones. The result was not what anyone expected. It was more dramatic than folklore. The Deep Maniots' paternal lineages matched no modern population on Earth. Their Y chromosomes traced back, unbroken, to the Bronze Age, before the Slavic migrations, before the fall of Rome, before the medieval period rewrote the demographic map of the Balkans. The oral histories were not myth. They were, in a measurable biological sense, true. But here is the part that matters beyond the Mani Peninsula. What the Deep Maniots preserve, in concentrated form, is a genetic signature that all Greeks carry, diluted but persistent, a signature that makes Greeks fundamentally different from the French, the Germans, the Scandinavians, the Irish. Different, in fact, from most of the people we casually group together as European. The question is not whether Greeks are genetically distinct. That has been confirmed so many times, with so many methods, that it is no longer seriously debated. The question is, why? What specific historical forces, spanning thousands of years, produced a population that sits in such an unusual position on the genetic map of Europe? And what does the answer reveal, not just about Greece, but about what European actually means? To understand this, you need to know what most people get wrong about European genetics in the first place. There is a popular assumption that Europeans are a single genetic population with minor regional variation. Northern Europeans are a bit paler, Southern Europeans a bit darker, but underneath, we are all basically the same stock. This is almost completely false. Modern Europeans are a mixture of at least 3, possibly 4, deeply divergent ancestral populations that met and merged over the last 10,000 years. And the proportions in which they mixed are not uniform across the continent. They vary enormously, and Greece sits at an extreme end of that variation. The first ancestral population is the Western hunter-gatherers, the people who inhabited Europe before farming arrived. The second is the Anatolian Neolithic farmers, who spread out of what is now Turkey starting around 9,000 years ago, carrying agriculture, domesticated animals, and a genetic profile that was radically different from the people they encountered. The third is the Western steppe herders, descended from the Yamnaya pastoralists of the Pontic-Caspian steppe, who swept into Europe around 5,000 years ago, probably bringing Indo-European languages with them. And the fourth, often overlooked, is a component related to the Caucasus hunter-gatherers, a population that weathered the Ice Age in isolation between the Black Sea and the Caspian. Now, in a Swede or an Irishman, the steppe component dominates. It can reach 50% or higher. The Anatolian farmer contribution drops to maybe 20 or 30%, and hunter-gatherer ancestry from both East and West fills in the rest. In a Greek, the proportions are reversed. Anatolian Neolithic ancestry in Greeks runs between 58 and 66%, the highest proportion in Europe outside of Sardinia. Steppe ancestry? Between 3 and 6%. In some ancient Greek individuals, it is completely absent. Where Northern Europeans are genetically half-steppe nomad, Greeks are barely 1/20th. And on top of that, Greeks carry a Caucasus hunter-gatherer component of around 20%, a signature that is almost entirely absent in Northern and Western Europeans, but connects Greeks to populations in modern-day Georgia, Armenia, and Iran. This is not a subtle difference. On a principal component analysis plot, where populations cluster by genetic similarity, Greeks do not sit with the Danes or the English. They sit with Italians, Albanians, and Western Anatolians. They sit, in other words, closer to the Near East than to the North Atlantic. So the obvious question becomes, how did this happen? Why did the steppe wave that transformed Northern Europe leave Greece largely untouched? The answer is one of the most fascinating stories in human genetics, and it starts much earlier than most people realize, about 9,000 years ago, when the first farmers crossed the Aegean. The Neolithic farmers who entered Greece were not a monolithic group. This is where the standard narrative breaks down, and it is worth slowing down for, because this single detail reshapes the entire story. When farming spread from the Fertile Crescent into Europe around 9,000 years ago, it did not move as a single wave. Recent analysis by Lazaridis and colleagues has shown that at least two genetically distinguishable streams of Anatolian farmers entered Europe along different routes. One stream moved northwest through the Balkans and eventually reached Central Europe, the Danube Basin, the Rhine Valley, the North European Plain. These are the ancestors of the linear band ceramic culture, the first farmers of Germany and Poland and France. The other stream crossed the Aegean, settled Crete and the Greek mainland, and seeded the populations that would eventually build Mycenae and Athens. Here is the difference that matters. The southeastern stream, the one that reached Greece, carried 8 to 10% Caucasus hunter-gatherer ancestry baked into their genomes from the start. This was a trace element acquired somewhere in southeastern Anatolia or the northern Levant, where early farming communities had been in contact with populations from further east, from the highlands between the Black Sea and the Caspian. Central European farmers lacked this component almost entirely. When a family of Neolithic farmers cleared land for wheat near what would become Thessaloniki, they were already, genetically, a fundamentally different people from the farmers breaking ground near what would become Berlin. From the very first generation of European agriculture, Greece and Northern Europe were on divergent genetic trajectories. Most popular accounts date the split between Greek and Northern European genetics to the Bronze Age, to the steppe migrations, to the arrival of the Indo-Europeans. That gets the timeline wrong by about 4,000 years. The divergence began with the Neolithic itself. Then something else happened that deepened the divide. Around 3,100 BCE, during the early Bronze Age, another pulse of Eastern ancestry arrived in the Aegean. This was predominantly of Anatolian origin, particularly strong in Crete, and it pushed the Caucasus hunter-gatherer component in the region up to around 18 to 21%. This is the genetic landscape we see in the Minoans, the first great Aegean civilization. The Minoans built palace complexes at Knossos and Phaistos. They developed a sophisticated writing system, Linear A, that we still cannot fully decipher. They painted frescoes showing dark-haired, dark-eyed people leaping over bulls and carrying bundles of saffron. And genetically, they were almost entirely Near Eastern in their ancestry profile. Around 75% Anatolian Neolithic farmer, about 18% Caucasus hunter-gatherer. And steppe ancestry? 0. Not a detectable trace. This means the people who built one of the earliest complex civilizations in Europe had more in common, genetically, with populations in the Caucasus foothills than with any population that would later inhabit Scandinavia or Britain. Let that sit for a moment. The cultural ancestors of Western civilization carried a genome that points east, not north. But if you are part of this channel's audience, you are already asking the next question. If the Minoans had no steppe ancestry, and the Greek language is Indo-European, and Indo-European languages are linked to steppe migrations, then how did Greek become, well, Greek? This is where the story gets genuinely interesting. And the answer involves a ratio that, once you see it, changes how you think about the entire Indo-European expansion. Around 5,000 years ago, the Yamnaya pastoralists began moving south from the Pontic-Caspian steppe. In northern Europe, this migration was massive, sometimes replacing up to 75% of the local gene pool. But in Greece, the genetic impact was radically smaller. Lazaridis and colleagues have estimated that the Yamnaya contribution to mainland Greek populations was roughly one steppe migrant for every 10 local inhabitants, a ratio of 1 to 10. That is enough to bring a language, especially if you are an armed, mobile, horse-riding minority inserting yourself into an agricultural society's elite structure. But it is not enough to overwrite the existing genetic profile of the population. And this is precisely what the DNA shows. Mycenaean Greeks, the civilization of Agamemnon and the Trojan War, carried only about 4% Eastern European hunter-gatherer ancestry, the signature marker of steppe migration. Most of their genome, roughly 75%, came from the same Anatolian farmer and Caucasus hunter-gatherer mix that characterized the Minoans. If you subscribe to this channel, you know we are working on a longer series about the Yamnaya expansion and what it looked like in different parts of Europe. The Greek case is going to be central to that series, because it shows something the simple steppe invasion narrative tends to obscure, that language replacement and genetic replacement are not the same thing. But there is a detail in the Greek data that complicates even this narrative, and it is one of the most striking findings in the entire ancient DNA literature. In 2022, Lazaridis, Reich, and 202 co-authors published 3 simultaneous papers in Science, the most ambitious ancient DNA study ever attempted for this region. They sequenced 727 ancient genomes from across the Southern Arc, the geographic bridge between Europe, Anatolia, and the Caucasus. Among the individuals sampled was the Griffin Warrior, a man buried around 1450 BCE near Pylos in the Peloponnese, in an olive grove just outside the Acropolis. His tomb had been missed by Carl Blegen, the archaeologist who discovered the nearby Palace of Nestor in 1939. When UC researchers Jack Davis and Sharon Stocker finally found it in 2015, what they uncovered inside was extraordinary. A gold-hilted sword resting on his chest, a twin dagger, bands of bronze from a suit of armor, boar's tusk fragments from a warrior's helmet, and a tiny carved agate seal stone, only 1.4 inches wide, depicting a warrior in combat with such detail that it stunned the art historical community. Archaeology magazine called it the greatest discovery in Greece in 50 years. By every material measure, this was an elite, one of the earliest Mycenaean kings of Pylos. His DNA showed 0 steppe ancestry. None. Not a trace. This matters because the standard model suggests the steppe migrants initially formed an aristocratic class, yet here was an elite, a king, whose genome was indistinguishable from a pre-steppe Minoan. Other Mycenaean individuals at the same site did carry steppe ancestry. Commoners and elites alike were genetically mixed in both directions. The implication is that Mycenaean society was not stratified along genetic lines. Whatever social hierarchy existed, it was permeable enough for someone with no steppe heritage to rise to the top. The same 2022 study revealed something else about Greece that separates it from the rest of Europe. In 2023, Irini Skortanioti of the Max Planck Institute and her colleagues published the results of ancient DNA analysis from 102 individuals across the Aegean, Crete, and the mainland, spanning from the Neolithic to the Iron Age. They found that roughly 30% of all sampled Aegean individuals showed evidence of consanguineous endogamy, being the offspring of parents who were first or second cousins. At one particular site on Crete, the cemetery of Hagios Charalambos, the rate was 50%. This level of within-community marriage is, and I need to emphasize this, unprecedented in the global ancient DNA record. No other ancient population studied anywhere on Earth has shown endogamy at these frequencies. Not Neolithic Britain, not Bronze Age Iberia, not ancient Mesopotamia, just the Aegean. What does this mean? It means that Aegean communities were small, tight-knit, and they married within their own networks, generation after generation, for thousands of years. This practice would have acted as a genetic buffer, slowing the dilution of local ancestry even when outsiders arrived. It may be one of the key mechanisms that explains why the steppe signal remained so low in Greece compared to the rest of Europe. Not because steppe migrants never came, but because the local social structure was resistant to large-scale genetic absorption. Now, if the Bronze Age established the core of Greek ancestry, what happened over the next 3,000 years? Did the crossroads of civilization erase it? Not as much as you would think. The Roman period brought administrative control, but surprisingly little genetic change. In fact, one of the most striking findings of the Southern Arc study is that Anatolian populations showed extraordinary genetic continuity from the Neolithic all the way through the Byzantine period. And those same Anatolians formed the demographic core of the Roman Empire itself, including the population of the city of Rome. The Mediterranean world, genetically speaking, was more stable than its political map suggests. The real disruption came later. After the 6th century CE, Slavic-speaking populations migrated into the Balkans during a period sometimes called the Barbarian Invasions. Much of the Greek mainland experienced demographic upheaval. Cities contracted, archaeological records thin out, and into this vacuum, new populations arrived. The German historian Jakob Philipp Fallmerayr proposed in 1830 that these medieval Slavic invasions completely extinguished the Greek population of the Peloponnese and replaced it with Slavic settlers. The modern Greeks, in Fallmerayr's telling, were not Greek at all. They were Slavs who had adopted the Greek language and Orthodox Christianity. This theory was politically explosive. It challenged the legitimacy of the newly independent Greek state. It has been debated, sometimes bitterly, for nearly 2 centuries. Modern genetics has settled it, definitively. A 2017 study in the European Journal of Human Genetics, led by George Stamatoyiannopoulos, used 2.5 million genetic markers across 241 individuals from every district of the Peloponnese. The results showed that while some Slavic-related admixture is detectable, particularly in northern and western regions closer to the routes of entry, the genetic core of the Peloponnesian population was not replaced. The Slavic contribution exists, but as a layer, not a replacement. The deeper Aegean foundation persists beneath it. The most isolated populations show the least Slavic contact, and no population demonstrates this more clearly than the deep Maniots. Their Y chromosomes show virtually no Northeast European paternal lineages, the kind that are common in other mainland Greeks, and that trace to medieval Slavic contact. 80% of deep Maniot men carry haplogroup JM172, a West Asian lineage linked to Bronze Age Aegean populations. Their genome is, in the words of lead researcher Leonidas Romanos Davronoglou, a snapshot of what Greek genetics would have been prior to the medieval times. And then there is the bottleneck. More than 50% of present-day deep Maniot men descend from a single male ancestor who lived in the 7th century CE, a period of plague, warfare, and economic collapse across much of Greece. The population of the Mani was probably reduced to a handful of families. Those families rebuilt. Their descendants are still there. But even the deep Maniots are not a simple story of purity. Their maternal lineages, the DNA inherited from mothers, show greater diversity, with contributions from the Levant, the wider Mediterranean, Western Europe, and even Africa. Women, it seems, traveled to the Mani from distant regions and married into the community. The men stayed rooted. The women came from elsewhere. This was a surprise to the researchers. Deep Maniot women have been historically understudied, And the evidence that ancient women traveled from far-flung regions to form families on this rocky, inhospitable peninsula was not predicted by any previous model. Patrilineal continuity coexisted with maternal cosmopolitanism. The towers remained in the same families. The bloodlines passing through fathers held firm, but the mothers who joined those families carried the wider world with them. This pattern, local male lineages persisting while female lineages show broader geographic origins, is actually visible across the Aegean Bronze Age data as well. It suggests a society that was patri, where women moved to their husband's community. A practice that would have reinforced genetic continuity along the male line, even as individual families incorporated outside connections. So here is where the genetic data leaves us. When you hear that Greeks are genetically different from other Europeans, the correct statement is more specific and more interesting than most versions of it. Greeks carry a deeper Anatolian Neolithic signature than almost any other European population. They carry a Caucasus component that connects them to populations in the southern Caucasus and Iran, a component that was present in the Aegean before any steppe migration and that most northern Europeans entirely lack. They carry less steppe ancestry than almost any population in Europe that speaks an Indo-European language. And these proportions have remained remarkably stable for at least 3,500 years, buffered by endogamy, geography, and social structure. Some of the debate in the field centers on whether this continuity is genuinely exceptional or whether Greece is simply part of a broader southern European pattern that includes Italy, Albania, and the Western Balkans. There is truth to both positions. The genetic distances between Greeks and Italians are nearly zero, so close that some studies report a negative FST value, meaning the populations are statistically indistinguishable at certain loci. Southern Europe as a whole retained more farmer ancestry and less steppe ancestry than the north. But within Southern Europe, Greece and Crete sit at the most extreme end of the spectrum, closest to the original Neolithic source, furthest from the steppe. There is also a live debate about the role of geography versus culture in maintaining this distinctiveness. Greece is a landscape of islands, mountain valleys, and coastal pockets, a geography that fragments populations and limits gene flow between communities. The Aegean Islands alone number in the thousands. The mountain spine of the Pindus Range splits the mainland. The Mani Peninsula is accessible only through narrow defiles. This physical fragmentation would have slowed the spread of any incoming population, even one as mobile as the Yamnaya. But geography alone cannot explain the pattern. The endogamy data from Scortaniotti's study suggests that social structure mattered as much as mountains. When 30% of a population marries within its extended family, generation after generation, it creates a cultural barrier to genetic integration that persists regardless of terrain. The question that researchers have not yet resolved is whether the endogamy was a deliberate practice, perhaps tied to inheritance rules or religious custom, or simply a byproduct of small community size and limited options. There is also a methodological caution worth flagging. Ancient DNA from the Mediterranean has been difficult to recover until recently. The hot, dry climate degrades genetic material, and much of the existing data comes from the petrous bone of the inner ear, which preserves DNA better than other skeletal elements. As sampling expands beyond cemeteries associated with palaces and major settlements, we will almost certainly discover more heterogeneity within ancient Greek populations than current data reveal. The picture is probably directionally correct, but will gain nuance. Certain regions, certain time periods, certain social classes may tell different stories than the ones we have now. What will not change is the fundamental architecture. Greeks are not genetically distinct because of a single dramatic event, not one invasion, not one migration, not one bottleneck. They are distinct because of an accumulation of conditions: a different Neolithic founding population, a Caucasus connection that deepened during the early Bronze Age, a social structure that resisted genetic absorption, limited steppe penetration, and a landscape of islands and mountains that fragmented populations and preserved local lineages. Today, when a Greek person takes a consumer DNA test and sees an ancestry composition that skews more toward Anatolian or West Asian than expected, they are looking at the trace of the first farmers who ever entered Europe, preserved more faithfully in their genome than in almost anyone else on the continent. They are looking at a Caucasus lineage that arrived before the pyramids were built. They are looking at an ancestry that predates not only modern Greece, but the idea of Europe itself. The deep Maniots, in their stone towers on the edge of the Mediterranean, are simply the ones who held on to it most tightly.